Hello and welcome to another video. In this video, we're going to be working on the LCA of a binary tree, and it's going to be the next problem in the Blend 75 in TypeScript. So we're going to be doing LCA of a binary tree where last time we did a LCA of a BST. So the difference here is now given a node, we don't really know where to look for the children, right? So if we're given like P and Q, this doesn't necessarily have to be a BST. So P and Q can be literally anywhere because there is no kind of like order that's maintained in a normal binary tree. So pretty much what we have to do is let's just kind of like draw these paths from the P and the Q to the root and kind of figure out like what we need. And that's going to be kind of similar to the last time, right? So for 5 and 1, we're going to draw up our paths all the way to the root. And the LCA is actually the node that these two first intersect at. So in this case, we would want to return 3. Similarly, if we have 5 and 4, if we draw up both of these paths, they are going to intersect at 5. So we'd want to return 5, and then, so that's going to be kind of true with any two nodes. Like with 6 and 4, you draw up the path to the root, and then whatever they intersect at, the first node they intersect at is your LCA. So really what we're asked to figure out is like to figure out, when making these paths, we just need to figure out what's the first node that these intersect at, and wherever that is going to be the LCA. And so the way we're actually going to do this is we're just going to be returning true or false from every node, and then basically let's just think of like some intersection possibilities. So let's say we have this node and this node. So essentially 6 is going to return true, 5 is going to return true. Like as soon as we find a node, we will just return true. And once we're at this 3, we're going to check the left, the right, and the current node for P and Q. So left and right are going to be true and true here, and the node will not be equal. So essentially, we're going to look for 2 out of these being true. And if 2 of these are true, then we're guaranteed to have the LCA. So let's kind of walk through some examples of that. So let's just like, we're going to use this tree, but let's just like look at some different nodes. So we have 7 and 0. And let's drop these paths. This path is going to be like this. And so the first node that 2 of these are true is going to be at 3, right? So we would just set our result to be 3. Let's take some nodes that are closer like this. So these 2 nodes are going to intersect at 5. So at 5, the left and the right will be true. So that will return. And then notice like once 2 of them are true, we're going to return if left, right, or the value is true. So even though here there are two things that are true, right, left and the right, we're only going to return 1 true value up here. So the only node that's going to be the LCA, this is the only node that 2 of them are going to be true, because we're just going to return true up here, and then this side will return false, like all this will return false. So there will only be 1 LCA guaranteed. Let's look at a couple more nodes. Let's say we have like 5 and 4. So we're going to return true up here, and now when we're at 5, the right side will be true, the left side will be false, but its value will also be equal to one of these. So that's 2 out of the 3, right? The right is true and itself is true. And then we're going to turn true up here, and same thing, all of this will be false, so none of these will be true. So that's kind of what we're going to do, is we're essentially going to return left, right, or the node, and then at every single node, we're just going to compare are 2 of these true, and if 2 of them are true, that's guaranteed our LCA, and we can just write that out to our output. And we can just do a basic, we can just do any kind of traversal that checks the root last, because we want to first check if the left and right children are returning true or false. Yeah. I guess technically you can check the node value first. It doesn't really matter, but we're going to be doing it that way. So we're just going to be going left, right, and then root, or it doesn't really matter which one you pick. Anyway, so let's kind of code that up now. And yeah, it's not super difficult. There's other ways to do this. The other way to do this, actually, that I could briefly talk about is, let's say we have P and 5 is 5 and 4. So what you can actually do is you can just look for P. So you can literally make a function that looks for a node. You can give it 5, let's say. And then you will just return the traversal from that node to the root. So in this case, we would want to return 5 and then 3, right? And similarly, we'll do the same thing. We can just call that function. We give it some kind of parameter of what node to search for. So for 4, the path will be this path right here. So we can return 4, 2, 5, 3. And then all you have to do is you have to look for like the first intersection, right? So essentially, what you need to do is you need to look for like, and you want to look at the very bottom, right? So you just pick one of these that you traverse, and you're going to traverse them left to right. And remember, the left is going to be like the bottommost node, and the right is going to be the root. And you just look for one node that appears in both of them, the first node that appears in both of them, right? So, or I guess what you could do is you could like traverse the other way, and it's going to be like the last node that doesn't appear in both of them. So that you could do it that way as well, right? So this like top level path should be the same. So you would essentially you can go right to left for both. So you'd say like, okay, these two are equal. So let's set 3 to be my result for now. These two are equal. Let's set 5 to be my result for now. And then this is different than this because this is out of bounds. So my result's 5, right? The last node that was equal is guaranteed to be your LCA. We could do one more example of that as well. So that's like another way you could do it. Let's just say we take I don't know, 7 and 0. So the path for 7 would be 7, 2, 5, 3. Similarly, the path for 0 would be 0, 1, 3, right? So same thing, you traverse them both starting from the right. These are the same, and then as soon as the two values are different, these are different, you just take whatever old value you had. So you just take 3, and that's your LCA, and that's going to be correct. So either one of those is fine. If the 2 out of the 3 is not as intuitive, you can just get both paths, literally make a traversal function that takes in an input node that you're searching for, and just pass that in as what you're looking for. That's actually how I originally did this before I saw the 2 out of 3 node solution, which I think is a little bit more elegant. So, but definitely not super easy to come up with when you haven't seen this before. So that's the one we're going to code, though, is 2 out of 3. So we're going to have a result. It's going to be a tree node or null. And we're just going to set it equal to null for now. Then we're going to have our traverse function. You can probably make this in one function, but I like to usually make a helper function for most of these trees. It just makes it a little bit easier, and it doesn't really cost you anything. So we're going to have a node, and we are going to return a Boolean. We will just simply update the result once our conditions are met. So if not node, we're obviously just going to return false because we haven't seen anything. Now we're going to go left. So we're going to traverse node.left. Then we are going to go right. And then we need to actually check for the current node. So we're going to say const current node equals node.val equals p.val or node.val equals q.val. So we're just checking, is this node equal to one of them? If it is, let's make it true. And then now we have to look for 2 out of the 3. And because this is TypeScript and these are Booleans, you can't add them. If you were doing JavaScript, I believe you can add them. Actually, in Python, you can just add Booleans directly. But in TypeScript, I don't think you can. So we're going to convert these to number. So we're going to say number left plus number right. There's probably like maybe a different way to do this, but this is fine as well. So we're going to convert them to numbers, and we're going to see, do we have 2 out of the 3? And if yes, we will update our result to be the node, because that's the LCA. And now we are just going to return left or right or cur, and that way we're only going to return one true value. So if this is the LCA, as you recurse back up, that will be there's only going to be one intersection point that 2 of these are true. And we have to call traverse on the root and return that result. And let's take a look. Oh, looks like we have an issue here. Oh, this should be null. Okay, there we go. And let's zoom out of this a minute. Let's take a look. Okay. And like I said, the TypeScript thing is all over the place. That's whatever. It's a decent solution, and it's going to be as good as you can go for this problem. So we're going to have O of n. I guess we can go through it, right? So for the time, we are looping through the tree, so that's going to be O of n. And for the space, and like that's all we're doing is we're just looping through the tree. All of this is constant time, right? For the space, we create a result which costs us nothing, but our worst case traversal here, it's not guaranteed to be height balanced or anything. So our worst case space is going to be O of n if our tree is completely unbalanced. It's going to be O of n. And yeah, I think that's going to be it for this problem. So hopefully you like it. And if you did, please like the video and subscribe to the channel. And I will see you in the next one. Thanks for watching.